Hello guys, welcome back at this engineering tutorials. So next topic in structural theory is type of beams, frames, and truss. So the beam is a horizontal structural element that is made up of wood, steel, or concrete that resists the lateral load coming from the superstructure utilizing bending. So it is expected to withstand shear force, lateral force, and bending moments. So what are the types of beams? So we have the determinate beams. So for statically determinate beam, equilibrium equation or condition alone can be used to solve the reactions. So the number of unknown reaction is equal to the number of equations. So example of determinate beams are simple beam, cantilever beam, and overhang beam. For cantilever beam, if the beam is fixed at one end and set to be free at the other end, it is termed as cantilever beam. The beam distributes the load back to the support where it is forced against a moment and a shear stress. Cantilever beam allow the creation of a B window, balconies, and some bridges. Simple beam is one of the simplest structural elements that uh, both ends rests on support, but it is free to rotate. It contains pin support at one end and a roller support at the other end. So based on the assigned load, it sustains shearing and bending. And for the overhanging beam is a type of beam in which the end proportion of the beam extends more from the support. It is the combination of both a cantilever and a simply supported beam. The overhanging beam is safe if you construct them in the right way, otherwise the beam may fail. An overhanging beam is used where it is not practical to provide support to the beam at one end or both ends. So the overhanging beam is mainly encountered in floor beam that extends beyond the exterior wall of a building to provide support to the balcony. Other type of beams are indeterminate beams. So first, statically indeterminate beam, equilibrium equations or conditions are not enough to solve the reactions. So the analysis of this type of beam is more complicated than the statically determinate beams. So the different types of indeterminate beam are prop beam, fully restrained beam, and continuous beam. For the fully restrained beam is fixed at both ends, so as shown here. And for the prop beam is fixed at one end and prop either at the other end or at any other point along its span. So if the simple support is removed, prop beam will become cantilever beam. Continuous beam is a structural component that provides resistance to bending when the load or force is applied. These beams are commonly used in bridges. So a beam of this type has more than 2 points of support along its length. These are usually in the same horizontal plane, and the spans between the supports are in one straight line. So structural frames are building frames. So the types of structural frames, we have the rigid structural frame. So the word rigid implies the ability to stand the deformation. Rigid frame structures can define as the structures having column and beams, made monolithically and acting together to tolerate the moments which are producing as a result of applied load, such as shown in the figure. Brace structural frame. So with this frame system, bracing are commonly provided between columns and beams to surge their resistance besides the sideway forces and lateral forces because of an applied load. Bracing is typically done by positioning the diagonal members amid the column and beams. This frame system offers more effective resistance against the wind forces and earthquake loads, and is also more effective than the rigid frame system. We have also the gable structural frame. So it has peak at their top. So these frame systems are used in places with chances of heavy rainfall or snowfall. So trusses. Trusses are extremely strong, well accepted, cost-effective option for the construction of various structures. To maximize the efficiency of the structure, which is often measured in material use or labor, an appropriate truss type should be selected for the design. So these are the types of truss. One, we have PRATT truss. It is being used over the past 2 centuries as an effective truss method. The vertical members are in compression while the diagonal members are in tension. This simplifies and produces a more efficient design since the steel in the diagonal members in tension can be reduced. So how truss are essentially the opposite of flat trusses in terms of geometry. In fact, looking at the flat truss upside down will visualize a how truss of sorts. The entire structure is still relatively the same, but the diagonal braces are now occupying the opposite or the unoccupied joints. This switch in position of the diagonal members has very important effect structurally. So just look the difference between your geometry configuration. We have also the Warren truss. The Warren truss is another very popular truss structure system and is easily identified by its construction from equilateral triangles. One of the main advantages of a Warren truss is its ability to spread the load evenly across a number of different members. This is, however, generally for cases when the structure is undergoing a span load or a distributed load. We have also the key truss. The key truss is slightly more complicated version of the Pratt truss. Its main difference is that the vertical members have become shortened, improving its resistance against buckling. It does, however, have similar pros and cons to the Pratt truss, and although it is not widely used, it is a strong design. One of its main disadvantages is that the members don't always behave as expected. A member may be in compression under one load scenario and in tension under another. We have also the pink truss. So the pink truss is its most basic form, has wave members that follow a V pattern which can be repeated several times. As the top chords are sloping downward from the center, the V pattern becomes noticeably smaller as pink trusses rely more on diagonal members. They can be very efficient at transmitting loads to the support. Other truss configuration are as follows. So we have the clear story, in scissors, gambrel, mono trusses. We have scissors and mono. Common trusses under spans. We have king post, uh, fan, long span, and so on. See you next time, and thank you for watching.